Your host, and welcome to another edition of the Quantum Institute podcast, where we talk about science, space, technology, and all of that crap, as long as it's so interesting and mind blowing. Basically, I love myself some mind blowing science. The bigger, the crazier, the better, is what I think. Anyway, a little about myself, in case you're just tuning in for the first time. I'm a amateur scientist with a heavy interest in quantum physics. Working on a couple papers and things like that. Other than that, I'm an entrepreneur, run my own business, and man, I just love basically started this because I just have a lot of thoughts and love talking about the subject, and thought I'd share it with you. I hope you like it as well. Take a bit of a casual approach. I'm kind of more of a, you know, dirty joke kind of guy than like any kind of uptight or anything like that. So we're gonna try and have some fun with this. Well, let's just jump right into the first topic of the day. One of the things that came out, I think this might be I'm not sure exactly when this is from. It's from Discover Magazine's last edition, so I'm not sure. So in the last couple of weeks, but they released a bunch of pictures and some photos of what they call the spider soldier suit, except that the whole article is about how it's based on basically popping the way geckos cling to walls to make an exoskeleton suit for soldiers, so that they can climb up basically any wall, any surface, no problem. Um, Great comparison to me for any of you guys who saw Mission Impossible 4, the one with Tom Cruise and the Burj Khalifa out in Dubai, where he's like hanging to the side of the building and it's, 10 million feet up and it's all crazy. Kind of like that, except it's not limited to glass. So, yeah, in that movie, I know that one of the big things, it was like some kind of like suction technology, I think. I just get confused between that one, and there was also kind of the magnety things, I think, in the first one. But this actually works a little bit different. Turns out the way geckos, they can cling to a wall, and they're just up there, is basically through electromagnetism. While one of their paws or feet or toes or whatever you call it looks flat, it actually has like hundreds and thousands of little microfibers, and these microfibers, each one of them has a lot of surface area and creates an electromagnetic cling. Exactly the same reason stuff sticks to you if you put on a T-shirt right out of the dryer. And but the reason that they can cling to the wall is that it's just they have lots and lots and lots of these little clingers, basically, and they're microscopic. Like if you have a pet gecko, you won't be able to see them. Um, Same, if I remember correctly, this is the same thing that spiders use to climb on walls as well. It's like a little electromagnetic charge. Turns out this works pretty damn well. So what was going on is there's photos of these guys basically climbing up a wall. Once again, Mission Impossible is probably the number one pop culture reference for this, and it looked pretty awesome. I mean, basically, it was like guys who had sort of pads attached to their hands. I think it was hands and feet, or maybe hands and knees. Let me see. But then they could just crawl up the wall. Um, I'll say this: when I saw the photos and I watched the video, like, I want one. This is one of those things you're like, this is technology almost giving me some kind of a superpower. So I feel like that's pretty exciting. Of course, this is used for a military application. And again, I have sort of a theory of my own, which is more or less that every time the military releases something that, to the public saying, look what we got now, look at this new technology, probably means that there's 10 other things that they're not telling about us that are equally as crazy or equally as gnarly or, inventive or anything like that. Man, this is so cool. This is so cool. All of you, if you get the chance, you should go to discover.com and check out this article. There's an excellent video by the scientists who are working on this, where they explain the technology, explain how it works. You know what I was saying about like all the microfibers and all that stuff. And it's really, I mean, it's really insane. And you see the guy climbing this thing. It's all I can say is it's super cool. Now, what would I use that for? I mean, part of me just wants it so that I could go, like, middle of the night, climb a skyscraper, or something along those lines. Just mess around with it to have fun. I mean, if you want to think of what I'm sure, in terms of the military applications, like spying, getting above enemy ridges, breaking into enemy building. I don't know. There's a million things there, but I think for me, the interest in civilian. Not really so much a military guy myself, but yeah, in civilian life, I mean everything from like window washers. Maybe not the most high tech use for it, but why not? To everything like making, I don't know, making objects, making lamps, things that can stick to a wall and stay. Like, you wouldn't need to put a tack into the wall, or you wouldn't need to put anything like that into the wall. You could just hang something. It should be kind of cool. These things can take, like the sheeting that they use to make it can hold a lot of just mass. It can just hold like, I mean, something like a like one sheet of it can hold like 600 pounds worth when it's like stuck to the wall. So if you think about it, there's probably a lot of crazy stuff you could do it. Maybe we could mount a flat screen to the wall without having to do any, without having to do any drilling or anything like that. You want to move it to different, want to redecorate, want to move it to a different part of the house, you can just kind of pop it off, stick it to another part of the wall without having to change anything and just take a second. That'd be pretty damn cool, I'll tell you that. I'd be into that idea. Well, actually, I don't have a TV at the moment, but one day, my friends, one day I will be a TV owner. But there's, this is one of the things, is like this is sort of the military is developed for a military application, but like, if you think about it, there's like millions of things that, putting something against a flat, that ideas where putting something against a flat surface and having it absolutely stick and stay in place could be huge, Yeah. Well, maybe let's move on to the next topic. This I got sent by quite a few people. I think I'm maybe developing a reputation for enjoying some of the more inadvertently hilarious parts of science discoveries. But basically, NASA is developing a technique to determine what exoplanet, or not an exoplanet, just what planets are made of. Like, what's their chemical composition? What do they have in the atmosphere? Is it like, do they have oxygen? Do they have nitrogen? Is it methane? What do they? This is really hard to do from a distance, as you can imagine. You can't send, if you can't send a probe to scoop up something from Titan, which is the planet in question, one of the moons of Jupiter that we're going to be talking about. How do you figure out what it's made of? Well, I've been using spectroscopy a bunch of times. I talk about spectroscopy a lot, which is probably indicative of, kind of my level of nerdiness, that I think spectroscopy is pretty damn cool. But if you don't agree, go screw yourself. Just kidding. But anyway, so spectroscopy is where you look at, basically you can look at the light rays bouncing off something. So the light rays bouncing off a planet. We look through a telescope when we see the image, but this is a computer that it reads all that data, and it can figure out from the spectrum of lights that are coming back, to a certain extent, what the chemical composition of the planet may be. one thing they've been able to do is recreate the smell of a planet. Um, as ridiculous as that sounds, it turns out that is actually a pretty good way of figuring out the balance of a chemical composition. So, if my understanding is correct, basically, if we analyze the light rays coming in, have like all the wavelengths and stuff like that, we can say, okay, there's some nitrogen, there's some oxygen, there's some methane. But if we do the smell composition, then they bring it back to a lab to try and recreate it using the chemicals they think might be in there. They can come up with a much, much more accurate picture. Basically, if they can make something that smells like the planet, then they know that they're pretty close because that's a pretty unique signature. So they did this with Titan, and turns out NASA itself says it smells like gasoline and farts. Well, interesting. Interesting. I don't know. I just thought that was kind of funny. But I also have a pretty juvenile sense of humor. I will be honest about that. So, but one of the important things about this is that methane is actually, I mean, that's given as like sort of like one of the life signatures. It doesn't necessarily mean that there's life on a planet, but from what we know of Earth, all the methane on Earth, as far as I know, all of the methane, I'm not 100% sure about that, does come from organic materials. So things break down, and so if an animal dies, that can release methane. Waste products, especially cows are the famous one. Cows produce a lot of methane, and leave it up to your imagination to figure out exactly how they do it. But I'm gonna say, like, you wouldn't be like super stoked to be in the room when it was happening. Um, so, but one of the things is for the NASA scientists, this is like a huge. I mean, basically, this is a really big discovery. Like the fact this process, the ability of them to recreate what an atmosphere may be out of, is extremely important if we ever want to get any serious work done on another planet. Titan is one of the Titan and Europa, I think, are two of the planets that they've talked about for a long time, as possible places where humans may visit, possible exoplanets where humans may visit. I don't know if if any of you saw Gattaca. Oh, that's such a good movie. If you haven't seen it, science is not bad. Ethan Hawke, not the hugest Ethan Hawke fan, but he pretty much nailed it in that. It's kind of like a sci-fi noir. It's a cool movie. It's a super cool movie. You get the chance, you know, something to watch with the girlfriend, the boyfriend, or whatever. It is very not bad. And one of the things with that, while that movie actually, the whole point is genetic manipulation. Basically, it's you know human beings have decided to start manipulating their genes to create kind of like perfect people to a certain extent. One of the plot points involves a trip to Titan that the main character is trying to make. It's going to be the first human man mission to Titan. So this is something that's been in popular culture for some time. It's also got a pretty awesome name for a planet, but I do get a little nerdy about the Greek mythology thing. So, that's to be expected. Um, yeah, well, moving on to our next subject. And oh, believe me, I am trying to get an interview with one of the scientists from this team. NASA guys are pretty hard to get a hold of, but if I can make it happen, I'll tell you, I got a lot of questions asked about this one. Plus, as funny as it is, like Titan smells like farts. This is going to be the type of tech that really determines a whole lot of things when it comes to space travel in the future. The more accurately we can see what a planet's made out of, more accurately we determine, like, is there water there? Is there ice there? Is there the possibility of life there? or is it just like a deadly gas danger zone that will kill us the second we set foot on there? So, you know, unlike Prometheus, we don't necessarily want to take our helmets off without knowing what the atmosphere is made of. In fact, we probably don't want to go there without knowing what the atmosphere is made of. So this is pretty interesting. Now, another subject I want to come up with, and this is up there with some of my favorite, kind of science topics to talk about. Is quantum teleportation. That has gotten a lot of attention. As many of you may know, there's actually been a lot of success doing basically teleporting like photons, like basically subatomic or subatomic particles. Did something called a buckyball, which is like, I think it's like carbon that's structured in a certain way. Basically, really, 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 really small particles. They actually have been able to teleport a certain distance. I think one of the most famous cases was in the Canary Islands. There's a laboratory where they have a setup that teleports from one, that does instantaneous teleportation from one of the islands to another for, I don't know, maybe they just got perfect environmental setup down there or something along those lines. But they keep doing it longer and they keep doing it more complicated. And so, of course, one of the big things that people keep asking is basically, when do I get my teleporter? When can I, Star Trek style, teleport from here to Shanghai, to go get some Xiaolong Bao, or from here to, I don't know, base on the moon? Turns out, unsurprisingly, this is pretty complicated. What you get is, there's a couple things that come along with this. There's a couple things to unpack here. So, the first one is that if we have the thing to basically teleport a single particle, there are a hell of a lot of particles in your body. It says here someone actually wrote a paper about this, where in order to do one, a personal teleportation, it requires 4.5 times 10 to the 42nd bits of information, which is somewhere between more particles than there are in the known universe, and like almost basically infinity. So this is basically, this is going to be one of the hugest parts of the technical problem here. It's so much information. I mean, it's already such a struggle for them to do one photon to launch one photon 100 miles instantaneously. But like any good tech, baby steps first, right? So the other problem is that doesn't work. It doesn't work that consistently. Right now, in order to do quantum teleportation in a decent way, I mean, it's such a delicate setup. It's like the type of thing where if you basically if you know anything about quantum physics, observation is a big key. So if you have some kind of, it doesn't work until you measure it. And it's like when someone looks at it or measures it, that's when the teleportation takes part. So it has to be done. So this whole thing has to be, completed in this incredibly elaborate, incredibly protected setup, so that because otherwise it's just like almost any disturbance to the environment can set it off early or something like that. And were you to step into the teleporter and do it yourself, you might end up like, what is it, Jeff Goldblum in The Fly, when I think one of those early things, he tries to teleport a monkey and he gets turned inside out. That's a pretty gross movie. God, I love David Cronenberg. I wish he'd go back to making like really gross movies again. They were so cool. Anyway, so it's if you're putting your life on the line, then you want to make sure that it works really, really well. Well, I would at least. I don't want to speak for you exactly yet. And yeah, I don't know. The other side of this is that teleportation may not be exactly what we think it means for a person. Basically, you're being torn down and reconstructed is an exact replica. Um, when you phrase it that way, it starts to sound like, oh, I die and get recreated? Is that what happens? And it's not exactly clear. I think this kind of comes down to possibly an element of science versus like spirituality. What is the soul? Things like that. That's not a debate that I know necessarily enough about to really get involved with, but it would make me want to ask a few questions before setting foot into that teleporter. As basically, it's not a space elevator or an instantaneous space elevator. It's more of a how do you call it? It's kind of like a break you down and build you up. Did you guys see if anybody saw the Prestige? Spoiler alert for the Prestige, for maybe it's about 5 years old. Cool movie at that, Chris Nolan. Another Quantum Institute recommendation, The Prestige. Sorry to sidetrack on this, but I just watched this movie recently. Man, it's so good. Um, the David Bowie plays Nikolai Tesla in that, and Tesla is one of the absolute godfathers and basically spiritual leaders of science in general. Just finished one of his autobiographies that was pretty fascinating, and he got some interesting views on life. But in this movie, basically, there's a guy who's trying to do a magic trick that he has something. It wouldn't be a teleporter but basically it's a copier. It would create like a copy of him, and then it would make a double of him, and then he used that as part of the act, and et cetera, et cetera. I don't need to necessarily tell you the rest of the ending, but that is effectively how this would work, except instead of making a copy, it destroys the original and makes a copy elsewhere. So awesome if somebody wants to teleport me chocolate bar, because I don't care if it's the original or the copy. Atom for atom, it's the exact same thing. It's going to taste exactly as delicious, like no problem. But if you're really going to get into the like, is this the same? Am I the same person afterwards, or is it just a copy of me? Um, I don't know if I want to find out. But on the tech side, holy shit, this is some cool stuff. So, and this is like really, this is like recent technology. This has gotten remarkably better in the last few years. Basically, there's a team in China, there's a team in England, and there's the team in Spain, in the Canary Islands. As far as I know, those are the three major ones. I might be missing one out. If I am, I apologize. But but yeah, it's just like they're pushing further and further. I think that basically the two sides of the challenge is distance, or actually three sides of the challenge are distance, consistency, and the amount of stuff they can send. So, distance is obviously you want a teleporter, one that can go 10 miles versus one that can go 10 feet for real world applications, whether it be sending a message instantaneously or even something along the lines of like, well, whatever you want to teleport. Yeah, the further you can do it, the cooler it is. Basically, that's how I think of it. Consistency is that it doesn't always work. So if you need this for some kind of like quantum messenger, where basically it's like, think of it like a cell phone text message, but there's no lag time. It happens instantaneously. Although I doubt that they're going to use that for text messages right away. But yeah, when you look at that perspective, then like the more stuff you can send, or objects, if you're talking atoms, multiple atoms, eventually, once again building up to me getting my chocolate bar, my Hershey's Crunch bar being teleported to me. Yeah, just more stuff they can send, the closer they're getting to that. And then finally, what was it? Consistency. Oh, consistency. Yeah, they just got to make sure they can do it all the time. That they can nail this every time. You know what I mean? Which I don't think they are up on yet. But of course, this is like the earliest of early stage technologies right now. I mean, it's incredible that they're even doing anything with this at the moment, let alone like, that this has gone beyond any stage of just pure theory. I mean, this is like one of those sci-fi staples that, like time travel, or I don't know, like phasers from. Actually, I don't really know what a phaser is, but or like a warp drive or a hyperdrive. Like we talked about in one of our previous episodes. It's one of those things that it just seems so sci-fi that it's kind of mind-blowing that they're actually able to, legitimately pull some of this off. So, well, I'll tell you, well, we are definitely going to keep our eye on that into the future, because this is, who knows? I mean, this technology gets good, it could really change the way certain things work. Again, quantum messaging, instant, sending something instantaneously from one side of the globe to the other, or from one side of the solar system to the other. Actually, going back to the, sort of the spectroscopic, or like exploring space thing, if you had something like this that could teleport, you could put it on a satellite, you could put it on a, deep space probe, launch that, or if you'd put on, like, for instance, like the Mars rover, if that had, if that was able to teleport samples back, think about that we could send something to Mars, and rather than having to build a little laboratory on the robot so that all the analysis is going on the robot, this is what we do now. It'll like scoop up a little handful of dirt, put it into the equivalent of its robot backpack, and the robot backpack has a little automatic lab that kind of analyzes everything. If we could basically send that sample, or an exact replica of that sample back to Earth, like, it's incredible. Think how much cool stuff we could do with it. Or like Jupiter or Pluto or something like that. If we really want to analyze what some of these planets are made of, whether to figure out, like, is there water? Is there, is there possibility that we could live there? Is there possibility that something else may live there, some other kind of life? That could be a huge first step towards doing that. Of course, there's also about 10 gajillion use cases for something, for a teleporter here on Earth. From I think one of the first things that comes to mind is like solving hunger issues. If it's, you need to get a lot of food someplace right away, or a lot of water someplace right away, and you have this instantaneous teleport, you don't have to build the pipeline, you don't have to have the logistics. It could simplify a lot of that processes. Now that is a long way in the future, but just to note that the applications really are there. Anyway, I think that'll about do it for this episode of QI. Sorry about that. Thank you. Thanks a million for listening, and yeah, we'll catch up with you tomorrow with some more science news. Hope you all have a great day. Don't do anything I would do, and stay out of trouble, but, get in a little bit of trouble. All right. Talk to you later.